Hi everyone, welcome back to my channel. Today we are going to go through 5C, reciprocals and asymptotes. Reciprocal probably one of the hardest topic of this entire chapter. So we need to pay attention to that. Okay. So first of all, let's go kind of do a quick review on asymptotes first. So let's say this one y equals x minus 1, okay? So let's find the main range. We kind of did this in 2 unit already, but we just quickly revise it, okay? So for x, to find the domain is quite simple because is a fraction that the denominator can't be 0. So x can't be, x minus 1 can't be 0, so x can't be 1. So this is an asymptote. Okay, so we just don't have value for that x equals 1. Okay, now we got let's look into y. Now a lot of you probably confused about y because you just can't pinpoint how it goes, but this is a really quick way. So you can assume x is infinity, so extremely big. Okay, so if it is extremely big, y would be 1 over infinity minus 1 here. So infinity is extremely big. Infinity minus 1 is basically the same as infinity. So 1 over infinity, 1 over extremely big is really close to 0, isn't it? So y is not 0, equals to 0. So that's also an asymptote. Okay, so it's really important when we draw a diagram like this, we draw the asymptote first. So we got x not equals to 1, so we got this one here. X equals to 1, that's the asymptote, and y equals 0 is also asymptote. So the x-axis, y equals to 0. Oh wait, sorry, y equals to 1. Sorry, that's x-axis. Now we got those two. Now to draw the diagram, we did another thing is when y equals to 1 and y equals to -1. The reason being that is where it kind of change. Okay, I'll show you in a minute. So if y equals to 1, y is 1, x minus 1 equals to 1, x equals to 2. So I just don't have much space to write it down, so I'm just going to do it in my head. So -1, that means -1, x minus 1 equals -1, x equals 0. So we got these 2 points here. Okay, so the reason we want those 2 points is because that is where the curve change course. What does it mean by that? Because if you think about it, from for this section here, you got for this section here is going to go this way. Yeah, you're going to get close to the line, but doesn't touch the line. Okay, that's important. And then on the outside is going to curve towards the x-axis, but doesn't touch the line. Yeah, that's where hyperbola is, and also this way is like that. Oopsie, can't hold it for too long. It's going to get really close to the asymptote, but don't touch it. And this way as well. Okay, that's how we draw that graph. I think this is a pretty good video on drawing and finding the main range of hyperbola. Let's move into something slightly more difficult. Okay, those three. Can you guys pause this video and see whether you can find the main range? Once you're done, we're gonna go through that together. Okay. So the first one, for x, 3 minus x is not 0, okay? So x is not 3, yeah? Domain's easy. Well, actually, I haven't really labeled it. So domain is all x, real x, and x not equals to 1. For range is all real y, y not equals to 0, okay? That's how we write that, just in case you're not sure how to write it, okay? So now, this one, 3 minus x is not 0, x is not 3, okay? Now, when x is extremely big, the notation is like this. Well, the notation is actually y equals the limit x to infinity. So x going extremely big. So 2 over 3 minus x. Okay, so when x go extremely big, basically is 3 minus infinity. 3 minus infinity is negative infinity, basically. And 2 over negative infinity is basically negative 2 over infinity. So the 2 can basically cancel out as well. You basically only have 1. So when the denominator go infinity, doesn't matter what the denominator is. If it's a constant, doesn't matter the denominator is always just really close to 1. Okay. So negative 1 over infinity is it should be really close to 0. So whenever the denominator is infinitely big, that number is really small. Yeah. It doesn't matter if it's positive or negative. It just go really close to 0. So 0 here. So y not equals to 0. Oopsie, my y look a little bit weird. Okay, so the domain is all view x. Okay, oopsie. All view x not equals to 3. The range is all view y. Y not equals 0. Okay, so I'm going to kind of skip writing the whole sentence here for the next two because it's going to take too long. Okay, in here, x plus 2 not equals 0, so x is not equals to negative 2. Yeah, for y, it's quite similar to the first one. When x is infinity, y is really close to negative 2 over infinity plus 2. So the bottom is infinitely big, so it's really close. It's really close to negative 1 over infinity. Is basically really close to 0. Okay, so y not equals to 0. So we got the domain range. Last one. Apologize, the school bell is Star Wars this week. Okay, now again, denominator can't be 0. 2x plus 5 not equals 0. 2x not equals to negative 5. You can use fraction or decimal, doesn't matter. So x not equals to negative 5 over 2, or x not equals to 2.5. Same thing. And for y, this one is really similar. If x goes to infinity, y is just 5 over infinity plus 5. Yeah, it's basically 0. Yeah, not equals 0. So those two. Just a quick tips. If the top of the fraction is a constant and the bottom of the fraction is a have polynomial in there, it's really likely that the asymptote is 0, because if the top of a fraction is remained as the constant, the bottom can go extremely big or extremely small, and yeah, it go down to being a really small fraction which is really close to 0. Okay, now the next bit is the hardest bit here. I take out question 4 and question 5 there because everything's really similar. So we're going to go through this one slowly, okay? So first, we got asked to do y equals x plus 1. So I did a graph here already. Y equals x plus 1. So the y-intercept is 1. Okay, so it's here. Now, and when x equals 0, y equals 1. When y equals 0, x equals negative. Whoopsie. I hate that bar on the bottom. Now these two, so that means the graph looks like this. Okay. Is that right? Nope, it's not right. I hate that. Sometimes they do really weird things. Okay, so like this. Right, so that is... oops, I messed up the other one too. Not again. Technology, hey? Okay. Right, this is y equals to x plus 1. Sure. Now, we can tell that if we do this, let's go to that a little bit later. Now, this is first bit done. We need to show the intercept on the axis. So this is 1 and this is negative 1, this is 1. Okay. So, sure. Now, show the point where fx equals 1 and fx equals negative 1. So for this part, I'm going to show you y in a minute. Just quickly do this now. So fx equals to 1, y equals to 1, then 1 equals to x plus 1, x equals to 0, y equals to negative 1, x equals to negative 1, negative 2. Okay, so 2 points. So you got 0, 1, 0, 1 here, 1 point already, and then you got negative 1, negative 2, negative 2, negative 1, negative 2, negative 1. So 2 points here. So this 2. Okay. I'm doing in black, make it easier to see. So there's 2 points. Okay. They're kind of important. I'll tell you why in a minute. Now we got. Oh wait. So actually, you kind of know because we kind of did this diagram here because they're the turning points. Okay. So one close to the for example, this kind of turning, not really called turning points, but I interpret that as a turning point. It's just like the way where you can go to the left and go to the right. I don't know what that is called, but I kind of call it turning point. Anyway, so the reason we do y equals to 1 and y equals to negative 1 is because if we do the reciprocals, well, I'll just do a reciprocal here. So reciprocal here, we're talking about 1 over fx here. So y equals to 1 over fx. So that means y equals to 1 over x plus 1, okay? When we do reciprocals, 1 over 1 is 1. So it's also the intercept between the original line and the reciprocals. That is why it's quite important. So I'll show you in another example later, but that's an important point when we need to draw reciprocals. Okay. We also have a way to write a reciprocal as well. So sometimes if you see f negative x, f negative 1x, this is also means reciprocal because you know the power of negative 1 is 1 over. Okay. So that is that. So we got these 2 points here, and we kind of know the reciprocal. We can work it out. Work out the reciprocal is 1 plus x is not 0, or you can just look at our original graph. When you cut through the x-axis, so that means it's the reciprocal. Okay. So when the original line cut through the x-axis, this is reciprocal. So x is not equal to -1. Okay. We got a reciprocal. I'm just going to draw a what color? Pink. Okay. So and we got the y equals 1 and y equals -1. So those two will be intercept between the original line and the reciprocal. Okay. So we got this one here. So the left hand side is going to close to the x-axis, but never going to touch it. And then on the other side, it's going to close to the y-axis, but not going to touch it. Okay. On the dot on the left hand side, again, we did this. Okay. And that's the graph. Okay. For B, I'm going to leave B to do. You can do a quick practice, but I can quickly draw that in if you want me to. I just use a different color, so green to draw original line. Okay, so you can pause this video and draw it yourself first, just to test your understanding. I'm just going to draw it here. Okay, when x is 0, y is 2. So this dot. When y is 0, x is 2. So 2 dots. So draw it here. Obviously not too accurate, but anyway, hopefully it's fine. And then again, the reciprocals will be red. When that green line cut through the x-axis, that will be reciprocal. So it will be this one. Okay. Apologize, it's a mess here. X not equals to 2. Wait. Oh, wait. What did I do wrong here? Whoopsie. Wrong case. Make a mistake here. It should be here. Oopsie. See, graph is a really difficult topic. Sometimes make mistakes too, so make sure you draw the graph carefully. It doesn't make silly mistake like what I did earlier. Okay, so we can easily find where the reciprocal is when that line cuts through x-axis, or you can also check 2 minus x is not 0, so x is not 2. Okay. It's a really quick way to look at the equation and check it out. So x not equals to 2. Now, another thing is you can, because we have 2 points that are really important, is when y equals to 1 and y equals to -1. These 2 points. Okay. What color I can use here to make it stand out a little bit? Well, let's do orange. Okay. So here, at this point, as you can see, it's kind of like what I call turning point, but it's not really turning points because that would confuse you with something else later. Now, and this is that, and this is this side. Okay. Yep. Cool. As long as you get a few points, so you can easily do that. You can easily do the graph. One thing really important is that you kind of need, when the graph intersect with x or y axis, you need to find out what the coordinate is. So for example, this point is, it kind of intersect the y axis. You need to find out what that is. Okay, so for original graph, so x is equal to 0, so y is 2. So this is 2. So that means this is half. 1 over 2 is half. Okay. Yep. So that is straight line. Straight line is kind of easy, but we need to move on to what about we do a quadratic equation. So we have one here. It looked kind of complicated, but well, we still need to do that. So let's give it a go. So for A, we need to work out y equals 1, because sometimes when we do quadratic, sometimes there's only option for y equals 1, and sometimes there's option to y equals -1 as well. So, well, let's give it a go, see whether we can find x equals 1 or y equals 1. So substitute y equals 1 in, 1 equals 1 over 3, x plus 1, x minus 3. Okay, so 3, we times both sides by 3. And then we expand the right hand side. You got x squared plus 1 minus 3 is minus 2x, and then minus 3. Okay. Yep, sure. You move 3 to the other side. 0 equals x squared minus 2x minus 6. Well, I don't think we can factorize this, so let's use the quadratic formula. Let's work out b squared minus 4ac first. And b squared is -2 squared minus 4, then times 1 times -6. That is 28. Okay, so x equals to negative b. B is -2, so -2 is 2, plus minus square root of 28. And then 2a, a is 1, so it's 2 on the bottom. So you got 2 plus minus third. Oh, yep. 28 is 4 times 7, so 2 square root of 7 over 2. All have a 2, they can simplify. 1 plus minus square root of 7. So x equals to 1 plus square root of 7, and x equals to 1 minus square root of 7. So we prove that. We show that. That's good. Now, so the points. Square root of 7 is about 2.6. So 1 plus square root of 7 is about 3.6. So 3.6 is somewhere here. And 1 minus 2.6 is about -2.6. So here. So we got the dots up. So A is done. Compare the graph. Show vertices, intersects. Okay, well, there's some intersects there. So when y equals 0, there's intersects, which is x equals to -1, x equals to 3. So -1, wait, what? -1 and 3. Oh, wait. 1 minus 2.6 is -1.6. So somewhere here. My bad. Got this wrong. And also, we need x-intercept. X equals 0. Y equals 2. X is 0, 1, -3, just a -1. So it's here. Got a few dots. Well, if you think about quadratic, is symmetrical. So if we got the two x-intercept, we can find exactly where the vertex is. Vertex is halfway between -1 and 3. So that would be 2, yeah. So x equals to 2, y equals 2. 2 minus 1 is 2 plus 1 is 3 times 2 minus 3. So -3. Wait, what? 2 plus 1 is 3 times 2 minus 3, which is -1. So 3 times -1. So okay. What? That is something wrong. 3 times. Oh wait, that's not 2. Sorry, that's 1. Halfway between -1 and 3 is 1. My bad. So 1 plus 1 is 2. 2 times -2 is -4. So -4 is 3. Okay, so -3 is here. Okay, what do we look like? We have enough information to draw a graph. It's symmetrical, so this one is here. We can draw a graph easily, so I'm going to draw this real quick. And this side as well. Okay, well, looks like a really nice diagram. This is pretty weird for me. Anyway, so we got a graph done. Cool. And we need to label all the intercepts. So this is -1, -1, that is 3, and the vertex is what? 1, -4 is 3. Okay, so the intercepts and the point vertices. Okay, well, everything's done. Great. Now, can we work out the range? So for C, the range for this original graph. Now, y can be everything above -4 is 3. That's another reason why we need to work out the vertices. So the range would be all real y. Wait, no, my bad. It's not. Would be y larger equals to -4 is 3. Done. Cool. Now, this is the hard part, okay? First of all, if we need to draw the reciprocal, y equals to f-1 x or 1 over fx. That means any intercept to x-axis will be reciprocals. So that means this is the reciprocal here, and this is the reciprocal here. Oopsie, can do better. Okay, oh, whoopsie. What did I say better? Here. Okay, 2 reciprocals. Oh, close enough. Anyway, you got these 2 reciprocals. Great. Now, the part here is, that's why we need to work out these 2 dots. Oh wait, let me get a different color, pink. All right, that's why we need to work out y equals to 1, because that is the intercept between original graph and a new graph. Yeah. So in here, that means everything between the reciprocal and this dot, anything between the reciprocal here and this dot here, will be a graph that really close to reciprocal. So it's going to go up like this and not going to touch the line. And then the bottom bit will be close to your x-axis. Okay. Same with the one on the left hand side. And then here. Okay. Now the hard part is the bottom bit. So we got 2 reciprocals, so that means we know that it's curved to either side. But we also have these 2 dots here. They are -1, so that means they are the intercepts of original line and the reciprocal. Okay. Now the vertex is negative. The vertex is negative 4 over 3. Now when we do the reciprocal would be y equals to 1 over -4 over 3, which is -3 over 4. So that would be also be the vertices for this graph as well. So -3 over 4 would be here. Yeah. So that would be the vertices here. So that means the graph goes like this. Okay, it's close to the 2 graph, but doesn't really touch the reciprocal, the asymptote, sorry. So yeah, the new graph look like this. So it looked like a sad face, or it looked like the mask of Scream. You guys seen that movie? Anyway, so this is how we do that graph. To practice a little bit more. Oh wait, sorry, we still have E haven't done. Wait, we did this bit. Now E, the range you kind of need to read it off the graph. Okay. For E here. So let's look at the top. So it can be any. Y has all the way y has all the values except when you go down to the x-axis. So that means everything above x, but because the x-axis is a asymptote, so it's not going to touch the x-axis, which is y equals 0. So y is bigger than 0, not equals to, because y equals 0 is an asymptote, okay? And also, on the bottom bit, all the values are below this dot here, this vertex here. So everything below and less than or equals to. So y less than equals to, that vertex here is -3/4. So -3/4. So that would be the range, okay? Cool. Now, the next bit, we got those graph here. We actually don't need the equation to find out how to draw the reciprocal. Give it a go. The hardest part here is C, and the other ones are quite simple. Give it a go. If you don't, I have the answer on the next slide, but I'm going to show you how to do. Should I do them all? You may as well do them all, okay? Well, not them all. Or, you know what? I just do A and C with you, okay? So, asymptote first, obviously. Whoopsie. What's going on? Did it just freeze? Oh no. Oh, okay. Okay, cool. It's back. Apologize for technical difficulties. So I'm going to do A and C, okay? Now, first of all, asymptotes, really important. So, whoops. When it touch the x-axis, that will be asymptotes. So asymptote here and asymptote here. Asymptote here and asymptote here. So I can't do better. I have to do one side at a time, otherwise it's really hard to gauge. Okay, so another thing is when y equals to 1 and y equals to -1. So 1's here, -1 look like is about here. Okay, here and here. Right, with those information, we can basically draw it. Okay, so this is vertices. Oh yeah, vertices is important too, but it happened to be 1 here, so easy. We just going to use that as vertices, and everything on the left hand side of the middle part is going to go up, and this one's going to go up too. Not going to touch the vertices yet. Now, in here we got in the right hand side here, we got where the y equals -1 is already, so we know that is the intercept. So you're just going to draw the rest of it, yeah. And then the left hand side is kind of symmetrical, so. Okay, now can we work out what the value of this point is? Obviously we can, because for the original graph, the y value is -3. 1 over -3 is -1 over 3. So we can work out that value too. Don't forget that little part here, otherwise you're not going to get full marks, okay? So asymptotes, important. And the intercepts of x and y intercepts, they're important too, okay? Well, to make sure you don't lose any mark, you need to label the asymptote as well, okay? I don't think you can use different color in your exams, but you can use dashed lines. It's just harder for me to do dashed line, so I'm not doing dashed line here. Okay, so B, I'm pretty sure you guys can do that. Probably the only hard part is the middle, but the middle is the middle here is an asymptote as well. So we got 1, 2, 3 asymptotes, and all the graphs just go different directions. Okay, I think you guys can do that. Now C is weird because it got a asymptotes in the original graph. What should we do with that? I'm going to show you, okay? So first of all, again, first step, always using asymptotes, okay? Do the asymptote first, you never go wrong. Okay, label that x equals to 1, x equals to 3. Okay, we go from left to right. Okay, from left hand side, so, well, 2 is here, so 1 is here, so this dot is 1, and also this dot should be 1 too. Okay, well, if it doesn't give you values, it's hard to, so roughly right should be okay. Now, y-intercepts in here, so we got a y value of 2 here, so 1 over 2 is half, so it should be here. Okay, so, well, you got 2 points. I think you got an idea of how to draw that. Okay, I know there's the asymptote here, but the asymptote doesn't affect on the left hand side, it only affects on the right hand side, so we can cut with the asymptote there. So this is 1 over 2. Okay, now the middle part, well, this is interesting because if -1 is here, so this is between -1 and 0. So you know the vertice, if it's 1 over something that is between -1 and 0, it would be negative something. Yeah, so it would be somewhere up here. So let's say that is 1/3. Let's say that is 1/3. So 1 over 1/3. Oh wait, no, let's say that's -1/3. So 1 over 1/3 is y is -3, isn't it? So that should be up there somewhere. We don't know what the exact value is, but we know it will be bigger than 1. Okay, and then the both sides should be a curve. That should be a parabola. Yeah. So yeah, that's the middle. Now the right hand side is the hardest one. We got an asymptote here. If the original graph has the asymptote, the new graph has the asymptote as well. If the original graph asymptotes 2, we use 1 over 2, which is half. So the asymptote here will be half. Okay, so there's another asymptote in this graph. Now we got a thing here, and between this point, we go to the top. It's okay to cover original asymptote, that's fine. And then the bottom bit, because it was an asymptote, it will be an asymptote for this one as well. So it's going to be like this. It's not going to touch the line. It's not going to touch the asymptote. It's just going to go really close to it, okay? We need to also label this asymptote y equals to half. Okay? Cool. I hope it helps, and once you're done, you can check the answer right here. Okay, so I didn't label the asymptotes, my bad, but I'm pretty sure you guys get the idea. Okay, cool. Before we finish, there's one little one here, because you're probably going to come up in one of your exams, so just need to get this done. The last question here in this exercise is probably the easiest one. Okay, so in here we need to write the precise equation for the reciprocal functions. Okay, well, for the original, we know that the denominator is not equal to 0, so that is not equal to 0. Okay, so x not equal to 2. Okay, now the reciprocal will be y equals to 1 over x minus 2. Yeah, would be x plus 2. Okay, so would be y equals to x plus 2, but really important, x not equals to 2. This is basically the equation for that. Okay, it's really important because this would be empty dot. So I'll show you how the graph would look like. So let me draw the x and y axis first. Now, x not equals to 2, so we know that x equals to 2 is an asymptote. Okay, well, let's draw the graph first. Y equals x plus 2 to draw a graph. The y-intercept is 2. And if x equals to 0, y is -2. Okay. graphs like this, and x not equals to 2, so in this line here, and do that as asymptote. X not equals to 2, okay? If you draw the graph, you go to the asymptote here, and it will be empty circle, okay? And then you expand out from there. Okay, so that would be y equals x plus 2 and x not equals to 2. Okay. I hope you enjoyed this video and you got the basic concept with reciprocals. We are going to continue on with more reciprocals later on, because this is basically the focus of this this topic. I give you a few questions to do. They're mostly graphs, so give it a go, and you can always check the answer with the work solutions. Okay, thank you very much for watching, and I'll see you next time.